Okay, so let's start. Are you guys here? Am I audible or not?
Yes, sir.
Yeah, okay. So this week I will talk about Cauchy, Euler and non-homogeneous differential equation. Okay, so let's go to the one note. Okay, so the form of the Cauchy Euler differential equation is like this. So this is the form of Cauchy Euler differential equation. But this is the n order differential equation. Okay, nth order ODE. But we will solve second order differential equation. Okay, so let's solve second order. So the second order Cauchy-Euler differential equation will be like this. Okay, so the idea behind this is we will assume a solution, then we will try to find what are the possibilities. Okay, so assume y equal to x raised to the power m is the solution. Okay, just like we did previously for constant coefficient second order differential equation. In that we assumed what? Can you tell me what we assumed in the constant coefficient second order ODE? What kind of solution we assumed, then we found the solution? Tell me.
E to the power ax
Ax or lambda
mx.
x. Okay,
Yes, sir.
but here we will assume y equal to x raised to the power m. Okay, so since we have assumed, now we have to find this thing. So y dash will be what? Mx raised to the power m minus 1. Okay, and y double dash will be m times m minus 1 x raised to the power m minus 2. Okay, and y is exactly like this. Now we will put all these three in the star equation. So we will get a times m minus 1 x raised to the power, you can see that here the power is 2, and when you multiply with x raised to the power m minus 2, it will become x raised to the power m. Similarly here it will be bm x raised to the power m. Okay, and here it will be c x raised to the power m equal to 0. Okay, now we will write like this.
Sir,
Yeah.
sir, why are you assuming y equal to x to the power m? Some other solution is also possible, sir.
Yeah, that is also possible, but the thing is, some differential
Because
equation. Yeah, tell me.
because sir, you already didn't know, sir. You didn't know, sir.
Hmm? What? Say me again.
Sir, I mean, till now you don't know,
Yes,
and you are assuming y equal to x to the power m.
yes. The reason behind this is we cannot solve all kind of differential equation analytically. Okay, so some famous differential equation has already been solved by using hit and trial. Okay, and this kind of differential equation is one of them. So people has been substituted this kind of solution in that and they found something. That's why only this kind of differential equation is very famous, and other kind of differential equation has not been solved yet. So numerically people are solving all those equations, and this is the only differential equation. In the case of partial differential equation, situation is worst. Okay, so that's why first we are checking whether what is the situation if we substitute this, and when we substitute this, then we get that yeah, there is a solution. That's why it is happening. Okay, are you getting?
Oh, okay, sir. Sir, in case of partial differential equation, there might not be you assume answer.
Yeah, in partial differential equation also people has assumed that let this is the solution. Okay,
Okay, sir.
these different
Okay,
differential equation are very famous. This form of the differential equation are very famous, and when researcher or scientist, you can say, when they solve a particular form of the differential equation, that differential equation has been named by that particular researcher and scientist. Okay, so you can say that that is a big contribution by them. So that's why we are assuming, I mean, this is the same way they have used. That's why we are doing like this.
okay,
Fine.
sir. Okay, sir. Clear,
Yeah,
sir.
in the
Clear,
case
sir.
of
Clear.
constant coefficient differential equation, the idea was when we take first order differential equation, they found solution. Okay, then the same thing they substituted in the second order, third order constant coefficient, they found the solution. So that's why we are always starting, let's assume that this is the solution. Are you
Okay,
getting?
sir.
But sir,
Okay, sir.
Yeah.
if you get the solution, then how we come to know that the solution that we get
Yeah,
is
they
is accurate?
people has already been solved that there is an existence of unique solution. Since that is not the topic of our syllabus, people has proved that this is the unique solution.
Okay, sir.
Okay, yeah, there is a condition of uniqueness. Okay, fine.
Yes, sir.
Okay,
Yes, sir. Fine, sir.
yeah. So you can see that here x raised to the power m cannot be equal to 0. So we are writing like this. Fine. Now you can see that this is a quadratic equation. Okay, so we can write a m square plus m times b minus a plus c equal to 0. Now you can see that we will get two roots of this quadratic equation. Okay, now again there will be three cases. Okay, based on the nature of roots, so we will discuss about that. Suppose for case 1 roots are distinct. Okay, so distinct roots means what you will get three roots for m1 and m2. So suppose you have one root is m equal to lambda 1 and second root is m equal to lambda 2. Okay, so in that case, when you get the root of this equation, that is the lambda 1 lambda 2, then you can easily write one solution is nothing but x raised to the power lambda 1, and other solution will be x raised to the power lambda 2. Okay, so based on the linear combination of the solution, because these two are linearly independent, so the solution will be, since you can see that I am taking homogeneous case. Okay, I am taking the case of homogeneous, so I will write YH. Okay, and that is also, you can say, in your GATE syllabus people usually write complementary solutions. Okay, but I am not writing here, I am writing homogeneous to distinguish between non-homogeneous and homogeneous. So I will write C1 Y1 plus C2 Y2. So this is the solution. Okay, for the case of distinct roots, this will be the solution. Now let's discuss about the case 2. when roots are repeated. Okay, so roots are repeated means what? M will be lambda 1 equal to lambda 2. So here what will be the root? You can see that the root will be minus b by 2a. And what is the b? B is this and a is this. So the roots will be minus times b minus a divided by 2a. Are you getting it? So I can write minus b by 2a plus 1 by 2. This is the root. Now you can see that I already know one solution. And what is that? Y equal to x raised to the power lambda 1. That is nothing but this, x raised to the power minus b by 2a plus 1 by 2. This is the one solution, but you know that this is a second order ODE, which means that there must exist other solution also. So from where I will get other solution? You guys tell me. I want to know other solution. What is the y2? Since you can see that there exists two solutions, right? One is this and other we don't know, because since these roots are repeated, so this is one root. What about the other? How we will solve that?
Sir, other is also similar, sir. X to power minus b by 2a plus 1.
The same
Plus
thing.
1 by 2.
Same thing. Other root will be same.
Solution
Yes, sir.
should be independent, sir.
Yeah,
That's why
solution
this
should
will
be
different.
independent. If you are saying that y2 will be also same, but that cannot be the solution, because solution must be linearly independent. Okay, so we will use again the same thing which we did previously. Okay, so we will assume let y2 will be u times y1. y2 will be u times y1 is another solution. Okay, we'll use the same thing. And since we have already did if other solution is like this, then we will directly use that formula. Can you remember? That will be nothing but 1 divided by what? Tell me. What will be the other solution? If other solution is in this form, then I can write y1 integral 1 divided by y1 square e raised to the power. I have already derived, isn't it? Tell me. This is the u and this is y1. So now the point is, yeah, I can substitute y1 here, everything, but what is p? What is p? Then what should be the value of p? Tell me, what is p here? What is p? Tell me, what is p? What was that? If you are not able, yeah, tell me.
Bx.
No. If you can recall, I derived this formula on the basis of this differential equation. Can you recall it? If this is the differential equation, then this p is this p. But in our case, this is not the form, okay? But then what we will do? We will convert this form into that form. For that, what will I do? I will divide this by the whole equation. Then the coefficient of this will be 1 and the coefficient of dy by dx will become p. Okay, can you see that? So after dividing, what you will get? You will get y double dash plus b by a 1 by x y dash plus c divided by a x square y equal to 0, which means that this is our p. Okay, now you can directly substitute here to get y2. So y1 we already know that. What is that? Y1 is this. So first I will write directly as y1, then 1 divided by here y1 square e raised to the power minus, and this is p, so this will become b by a 1 by x dx and dx. Okay, so y2 will be y1 1 divided by y1 square. Now I can take this one as a outside, and this integral will become what? ln x. Okay, so I can rewrite is like this. You can see that I can also write ln mod of x raised to the power what? Minus b by a. Okay, dx. Can you tell me what I can write here? In the place of this, what I can write? Tell me. I already taught, no, the properties of logarithmic. So I can directly write x raised to the power minus b by a. Okay. So y2 equal to, now I will substitute what we got. And what was y1? y1 was this thing. So x raised to the power minus b by 2a, x raised to the power minus b by 2a plus 1 by 2. 1 divided by, when you multiply by 2, you will get x raised to the power minus b by a plus 1. And again here it will be minus b by a dx. So y2 will be x raised to the power minus b by 2a plus 1 by 2. You can see that x raised to the power minus b by a, and this will be cancelled out. It will become 1 by x dx. So this will be, I will write this again, I mean y1 in the form of y1. Okay, so you can see that this is nothing but the ln x. Okay, so you can see that another solution is nothing but y1 ln x. So which means that I can write overall solution is like this: c1 y1 plus c2 y1 ln x. Okay, so this is the solution. Okay, and what was the solution in the case of constant coefficient ODE? In the case of constant coefficient ODE, what was the another solution in the case of repeated roots? Tell me.
1 plus 1 plus x e to the power mx. Yes, sir. C1 plus C2 x
Yes.
bracket.
Another solution was x times y1.
Yes, sir.
Okay, so that was the case of when coefficients are constant. But in this case, the solution will be y1 ln x. If you want to simplify it, you can also write c1 x raised to the power lambda 1 plus c2 ln x x raised to the power lambda 1, or in the simplified form you can also write x raised to the power lambda 1 and c1 plus c2 ln x. This is the solution of the homogeneous part. Fine.
Sir, now it is generalized, sir.
Yeah.
It is generalized equation.
Yes.
Okay, sir.
This is the family of the solution. This is the family of solution. If you have boundary condition or initial condition, you can get C1 and C2 also. Okay, that will be particular solution. Okay, but yeah, it is a family of solution.
Okay, sir.
Fine. Okay, now let's
Fine,
move
sir,
to the
fine.
when roots are complex, case 3. Okay, roots are complex. Okay, which means that roots will be in the form of like this. Can someone tell me why complex roots are like this? I can. Why is that? Why I always write like alpha plus I beta, alpha minus I beta? Why it's like that? Why both complex roots are in this form? A plus minus IB. Why it's like that? Complex roots are always in conjugate pairs. You know that?
Yes.
Yeah, in conjugate pairs. That's why when you find the root, you will get something like this. Now, again you can see that since these two roots are distinct, so I don't have any problem to write in this form. So what is that? C1 x raised to the power x raised to the power alpha plus I beta plus C2 x raised to the power alpha minus I beta. Okay, I will simplify much more. So I will write x raised to the power alpha C1 x raised to the power I beta plus C2 x raised to the power minus I beta. I will write like this. Okay, now I will again write in another form. What is that? I will write ln e raised to the power xi beta. Is that fine? Tell me. No, I wrote wrong.
Fine, sir.
Yeah. Wait. I can write e raised to the power ln.
E to the power
yeah.
ln
Yes.
x. Yes, sir.
Okay, and here I will write e raised to the power ln x minus I beta. Okay, I will take this. I'll first simplify this, then I will talk about that term. Okay, so here you can see that I can also write e ln x raised to the power I beta as like this, e raised to the power I ln x raised to the power beta. So again, from the Euler identity, what I can write? I can write cos ln x raised to the power beta plus I sin ln x raised to the power beta. Okay, if you further simplify it, I can write cos beta ln x, okay, plus I sin beta ln x. Okay, now again if you write for this term, that is e raised to the power x raised to the power minus I beta, so you can write cos beta ln x minus I sin beta ln x. Okay, now substitute that, you will get homogeneous part is like this, x raised to the power alpha, and when you substitute that, you will get C1 plus C2 cos beta ln x, okay, plus IC1 minus IC2 sin beta ln x. Okay, so we will assume this as a capital A, this will as a capital B. So this is the final solution. So this is the final solution in the case of complex roots. Any doubt here? Tell me.
No, sir.
Okay, so let's take one example and we will see that how we can solve all those problems. Suppose you have a differential equation like this. Okay, so in this case, what will be the characteristic equation if you substitute y equal to x raised to the power m? What will be that? Tell me. What will be the characteristic equation in this case if you substitute this directly into this? Tell me. 4 times m minus 1, okay, plus
m minus 1 plus
17 equal to 0.
17 equal to 0.
So that will be 4m square minus 4m plus 17 equal to 0. Now you can see that root will be complex. So solution will be 1 by 2 plus 2i, and another root will be 1 by 2 minus 2i. Okay, so solution will be very simple form. What will be that? Tell me, what will be the solution?
X square.
Not x raised to the power 1 by 2. Okay, then a cos, okay, 2 ln x. Can you see that? Plus b
Yes, sir.
sine 2 ln x. This is the solution of this differential equation. Fine?
Fine, sir.
Yeah. So this was the case of homogeneous. I am talking about the homogeneous. I didn't talk about the non-homogeneity yet. Okay. So this is the form of Cauchy-Euler differential equation. Now let's move to the non-homogeneous ODE. Okay. And we will see how we will solve all those problems. Okay. So in the case of non-homogeneous, the general solution will be something like this. Okay, so you can see that this is nothing but the solution of the homogeneous part, and this we called as a particular solution. This comes into the picture because of the non-homogeneity. Okay, so now the point is how we will get yp. Okay, so there are many ways. So the famous ways to get that is this. Okay, that is method of undetermined coefficient. Okay, so in this, suppose we have a differential equation like this. Okay, any kind of differential equation I can write in this form. Not any kind, I mean linear. Okay, so we will use one table. Okay, and that table is this. Suppose the term Rx is something like this. Then for this choice, we will assume Yp is something like this. Okay, I will talk about it, how we will solve it. This is the gamma. Okay, and suppose the Rx is something like this. Then the choice of Yp we can use like this. Okay, and suppose you have Rx is something like this or like this, then in the both case we can assume this is a capital K, this is a small k, okay? So we will assume yp is something like this, k plus m sine omega x. And the last is, suppose you have Rx is like this, a raised to the power alpha x cos omega x, or k e raised to the power alpha x and sine omega x. Then in this case you can assume this kind of solution, gamma e raised to the power alpha x k cos omega x plus m sine omega x. Okay, again here we are assuming that suppose Rx is something like this, then the choice for yp will always be like this. Okay, then we will follow some steps. What is that? Step 1, solve ODE for homogeneous part. First will be solve for the homogeneous part, okay, and that solution will be something like this, c1y1 plus c2y2. First we will solve the homogeneous part, then we will follow the step number 2. And what is that? Pick one of the form of yp in from above table, okay, then substitute into ODE, okay, then find coefficients, okay. After finding that coefficient, that will be nothing but yp, okay. Now that is not the yp will come later. Why is that? I will tell you. Suppose we have Rx is something like the combination of all these. Suppose yp will be something like k e raised to the power gamma x plus k raised to the k x raised to the power n. Then in that case we will use the principle of superposition. If there is a combination, then use superposition principle. Okay, and then step 4 will be just write like this. Are you getting it? What I'm trying to say? Tell me. If you're not getting, let's solve one example. I have a differential equation is something like this. Okay. So what will be the characteristic equation? That will be lambda square plus 1 equal to 0. And from here I will get lambda equal to I and lambda 2 equal to minus I. So clearly you can see that homogeneous solution will be nothing but C1 cos x plus C2 sin x. This is the homogeneous solution. But we have this non-homogeneity. For that we will refer this table. You can see that if the non-homogeneous part is something like this, then we can assume particular solution is something like this. So let yp, you can see that the highest degree of the x is 2. So I will start like this: ax square plus bx plus c. Now I'll substitute directly into this. Then you will get, first I will get the first derivative, that will be 2ax plus b, and the second derivative will be 2a. Okay, and substitute this into that differential equation. So you will get 2a plus ax square plus bx plus c equal to 0.001 x square. Now take all coefficients separately. So you can see that x square has this coefficient, x has the coefficient b, that's it, plus c plus 2a equal to 0.001 x square. Now compare all the coefficients which are in the left hand side from the right hand side. You can see that here a equal to, that is nothing but 0.001, and b, you can see that is there is no such term which has x, so that will be 0, and also there is no such constant term, so I can write c plus 2a equal to what? 0. Now since we already got a, so you can get c equal to what? Minus 0.002. So problem is solved. So what is that yp? Yp is nothing but 0.001 x square plus 0 minus 0.002. So this is the yp, and what is the general solution? Will be c1 cos x plus c2 sin x plus 0.001 x square minus 0.002. This is the general solution of this differential equation. Are you getting it? This is the method of undetermined coefficients. Any doubt? Any doubt?
No, sir.
Yeah. Okay. Let's take one more example. Since you can see that we didn't use principle of superposition. So let's take one more example where I can use the principle of superposition. So suppose I have the differential equation is something like this. Okay, so in this case, first I will write the characteristic equation, that will be lambda square plus 2 lambda plus 0.75 equal to 0. Okay, so in this case, when you find the root of this characteristic equation, you will get lambda equal to minus 1 by 2, lambda 1 equal to minus 1 by 2, and lambda 2 equal to minus 3 by 2. This is the straightforward solution. That is what? That is c1 e raised to the power minus 1 by 2x plus c2 e raised to the power minus 3 by 2x. But this is not over, because this is the solution for the homogeneous part. Now you can see that in the non-homogeneity there are two forms. This is one form, okay, and this is another form. Okay, so we will solve this problem by fragmenting these two separately. So suppose I will solve for the first non-homogeneous part. So I will assume, you can see that this is the form of this. This is the form of this. So for that I will use this form for the yp. And what is that? K sine. You have to be very careful, because you can see that the constant of x is 1. So for that also I will use x only. K plus m sine x. Okay, I assume that. Now I will get the first derivative, that is k cos x. Oh yeah, it should be here, it should be cos, and it should be sine. So minus k sine x. and here it will be m cos x, and what will be the second derivative? Minus k cos x minus m sin x. Okay, I will substitute these three into that differential equation. So you will get minus k cos x minus m sin x bracket plus 2 times minus k sin x plus m cos x plus 0.75 multiply k cos x plus m sin x equal to, I will write this only. Okay, I will not write this. So that will be 2 cos x minus 0.25 sin x. Okay, again I will do the same thing. I will compare all those coefficients. So that will be, if you take common as a cos x, you will get minus k plus 2m plus 0.75 k. Okay, if you take common as a sin x, you will get minus m minus 2k and plus 0.75 m equal to 2 cos x minus 0.25 sin x. Okay, so you can see that this is equal to 2 and this is equal to this. So after comparing, you will get, if you simplify this, you can write minus 0.25 k plus 2m equal to 2. This is the equation number 1, and the second equation will be minus, you can see, minus 0.25 m minus 2k equal to minus 0.25. This is the equation number 2. Okay, now you can see that the solution, after solving this, you will get k equal to 0 and m equal to 1. If you solve this system of linear equation, you will get this. So simply, what will be the yp1? Yp1 will be this only. You can see m equal to 1, which means that I can write only this. So this is just sufficient to solve that. Now again I will solve for the yp2. Okay, so that is the only this form, so I can write a plus bx. I will assume this. So what will be the first derivative? B only. And what is the second derivative? 0. Directly substitute that. You will get 0 plus 2 times b. That is 2, no? 2 times b, yeah. 2 times b and plus 0.75 plus 0.75 a plus bx. And what is on the right hand side? That is plus 0.09. Okay, if you compare, you will get 0.75a plus 2b equal to 0. And if you compare the coefficient for b, you will get 0.75b, and that is x, no? So that will be 0.09. Okay, so from here, if you solve it, you will get b equal to 0.09 divided by 0.75, that is 0.12. And if you substitute this into this, you will get a equal to minus 0.32. That's it. So that will be, what is the solution? Yp plus yh. Okay, just combined all those by the combination of linear. Okay, so what is the yh? We already got, that is this. Okay, so I will write like this only, plus what is the yp? That is plus yp1 plus yp2. So yh, and what is yp1? Yp1 is just like cos x. And what is yp2? A plus bx. So minus 0.32 plus 0.12x. This is the solution. And at the place of YH, you can directly write this. Okay, so this is the complete solution if you want to use the superposition principle. Fine? Tell me, any problem here?
No, sir.
It's a simple and straight, nothing to worry about that. Okay, so this was the one way to solve the non-homogeneous part. Okay, there is another way to solve non-homogeneous part. Here it is a very simple because we have the very limited choice like this. And what if we don't have these choices? Then what we will do? Okay, so there is another method that is called variational principle. Not variation principle, variation of parameter. Variation of parameter. This is another way to solve non-homogeneous part. Any doubt? Tell me. No? Should I move? Tell me. Any doubt?
No, sir.
Okay. So, for the variation of parameter method, we have to again assume the differential, if the differential equation is in this form. Here you have to be very careful, okay? This method will only work if the differential equation is in this form. If differential equation is not in this form, then you have to change it. Okay, you can see that the coefficient of y double dash is 1. Okay, so you have to change if differential equation is not in this form. And again, the solution is in this form, yx equal to yhx plus ypx. But what is yp? This is the question. Okay, so the yp will be something like this. If y1 and y2 are the solutions of homogeneous part. Okay, to get yp, first you have to get y1 and y2. Anyhow you have to get it. So the solution will be in this form. And what is that? This will be minus y1 integral y2 r divided by w dx plus y2 y1 r divided by w dx. Can someone tell me what is w?
Wait function, sir.
What is w?
W is
What is that?
what?
I use this term many times. The w is nothing but the Wronskian. Okay, this is w, and that is nothing but y1, y2, and the first derivative of y1 and first derivative of y2. And this expression can also be used to check whether y1 and y2 are linearly independent or dependent. Okay, okay, so from this expression I can get particular solution if you know y1 and y2. I will not go to derive all these equations because this is out of the scope. I can also derive it, but it will take some time. I will give you one reference book you can check there, but for now I will not derive it. Okay, you can directly use it because this expression is not very complicated. Okay, So let's take one example how we will solve it. Suppose you have one differential equation something like this. You can see that this kind of differential equation cannot be solved by using the undetermined coefficient method, because we already discussed that undetermined coefficient have some limitations. We can only use for very special cases, but this is very special. You can see that we cannot use it. Okay, so for this form I will use the variation of parameter method to get the particular solution. So first, what is the homogeneous solution? You can see that the characteristic equation is this. So the lambda will be I and lambda 2 will be minus I. So YH is very simple, that is C1 cos x, okay, plus C2 sin x. So can someone tell me what is Y1 and what is Y2? Because to get to get particular solution, we have to know what is Y1 and Y2. Can someone tell me in this solution what is Y1 and what is Y2? Tell me. You already know that for the second order differential equation you will get two eigenvalues. If both are distinct or complex, you will get two eigenvalues, which means that you have two solutions. And always all those solutions you can write in this form, C1 Y1 plus C2 Y2. You can see that this is Y1 and this is Y2. Okay, so Y1 is what? Cos x, and Y2 is what? Sin x. Okay, so first I will get Wronskian. Wronskian is nothing but the cos x, which means that y1 y2. Okay, and the second row will be the derivative of this, that is sin x cos x, and when you solve this determinant you will get 1. Okay, so what will be the Wronskian? What will be the particular solution? That will be minus y1, which means that cos x, integral y2, that will be sin x into rx. In the case of rx it is sec x, divided by Wronskian, that is 1 dx, plus y2, that will be sin x, multiply y1, that will be cos x, into rx, that is sec x, divided by 1. So yp will be minus cos x. You can see that this is nothing but the tan x plus sin x, and this is 1. Okay, so yp will be minus cos x, and you already know that the integral of tan x is nothing but the ln sec x. Okay, or you can say that minus ln cos x. Okay, plus, and the integral of this will be x, so x sin x. Okay, so yp will be, if you absorb this negative sign into this, you can write cos x ln cos x plus x sin x. Problem is solved. Now what is the general solution? It will be c1 cos x plus c2 sin x, and just write all these terms. That will be cos x ln cos x plus x sin x. This is the complete solution of this differential equation. Is there any doubt? Tell me.
No, sir.
Fine? Everything fine? Is everything going
Yes,
good?
sir.
Yes, sir.
Okay. Okay, so I think I have covered everything, except there is one more thing. Sometimes GATE I think GATE has asked one question regarding the system of first order linear ODE. Okay, so yeah, I will discuss that thing also, because we cannot take the risk. Okay, so there is one more topic, that is system of linear. linear first order ODE. And what is that? It is something, if you know the solution of the system of linear equations like ax equal to b, then that principle and that everything, those theorems can be applied here. And what is that? Suppose you have a system of linear first order differential equations, something like this. This is the first equation. And the second equation is and nth derivative is something like this. Okay, if you have this kind of system of linear first order ODE, then how we will solve it? Let's see. First, I will write all this system in the matrix notation. So in matrix notation, I will write like this: capital X as this, x1, x2, x3, x4 and xn, all are function of time t. Okay, and matrix A I will write like this: a11, a12, a13, a1n, a21, a22, a2n, an1, an2, ann. Okay, so you can see that. And also I will write this, that is x1 dash, x2 dash, x3 dash and xn dash. So this equation can be written like this. Can you see that? The whole equation can be written like this, and this is actually homogeneous, because if it is non-homogeneous, then there will be one more elements, that is f1t, f2t, ft3. If it is a non-homogeneous, then you can also write f1t, f2t, fnt. If there is one more term which are independent of x1, x2, x3, suppose you have one another term, that is f1t, here f2t, then that kind of differential equation will be called as non-homogeneous system of first order differential equation. But we will solve first homogeneous part. Okay, so what we will do, let's take one example. In simple way, suppose you have differential equations like this. Okay, so clearly you can see that in this form, capital X is nothing but x and y. Okay, and matrix A is 3, 4, 5 and 7, and f is 0. Okay, and what is x dash? That is nothing but x dash and y dash, or you can write dx by dt or dy by dt. Okay, this is a simplified version of the linear system of first order differential equation. So now the point is how we will solve this kind of differential equation. If you write in the form of matrix, then you can see that I can always write like this. Okay, system of first order linear equation I can write like this. Again I will assume let x equal to k e raised to the power lambda t is the solution. Okay, here you can see that here k is actually a what? K is a vector, which means that that is the order of n by 1 vector, because this cannot be a vector, this is a scalar, and this is also a vector, which means that there is a column here. K is something like this: k1, k2 and kn. Okay, and x, you can see that that is nothing but the x1, x2, something like that. So this is the scalar, and this is the, suppose I am assuming that let this is the solution of this. Okay, now I will differentiate this with respect to time t. Then you can see that lambda will come here and it will become lambda k times e raised to the power lambda t. Now substitute into this, so you will get lambda k e raised to the power lambda t equal to a x, and at the place of x I can also write this k e raised to the power lambda t. Now I can write a minus lambda I times k e raised to the power lambda t equal to 0. Again, since e raised to the power lambda t cannot be 0, then I will arrive a matrix equation is something like this. You can see that this is nothing but the eigenvalue problem. Eigenvalue problem. Okay, and the thing is, we don't want a trivial solution. If you get a trivial solution, then you can see that all solutions will be 0. If you get a trivial solution, then all solution will be 0, and because of that we need the rank of the matrix should be the order of the matrix minus 1, which means that this matrix must be a singular, okay, to be a non-trivial solution, because the trivial solution will be what? K equal to 0, and if you take k equal to 0, then all solution will be 0, which means that 0 solution will always be the solution of this this matrix equation, but we don't want. So for that we need infinite number of solution, and for infinite number of solution, that is nothing but the non-trivial solution. In that case, the determinant, or you can see that this matrix must be a singular, which means that what? The determinant of A minus lambda I must be equal to 0, and for that we will get one characteristic equation, and after that we will get lambda. Okay, so what is that characteristic equation? That will be nothing but minus lambda raised to the power n, and or you can see that in the general form you can write like this: lambda raised to the power n plus p lambda raised to the power n minus 1 plus p1 p2 lambda raised to the power n minus 2, something like this. Okay, so again there will be a situation, whether lambda, I mean eigenvalues, are repeated or imaginary or distinct. Okay, but one thing it is very clear, that when you solve the problem, in many problem you will see that matrix A will be very symmetric, and if the matrix is symmetric, which means that lambda will be distinct and real. Okay, so we will assume case 1, if lambda is distinct. Okay, if lambda is distinct, which means that you will get, suppose it is a n order matrix, then you will get n lambdas. Okay, So that will be lambda 1, lambda 2, lambda 3 and blah 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 lambda n. And based on that you will get eigenvector. And what is that? This k. This k is nothing but the eigenvector. After getting lambdas, so for each corresponding lambda you will get eigenvectors. Okay, so for corresponding lambda 1, suppose you get eigenvector k1, k2, k3, kn. Okay, if you get it, then the solution will be something like this: c1 k1 e raised to the power lambda 1t plus c2 k2 e raised to the power lambda 2t plus dash 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 cn kn e raised to the power lambda nt. And you have to be very careful that this is actually a vector, because this is a column matrix and this one is also a column matrix. All these are column matrix, except this is a scalar and this is scalar but a function of time t. Okay, so this is the case 1. Let's solve one problem, then we will see it how we are getting it. Suppose you have one problem like this: y1 dash equal to minus 3y1 plus y2, and y2 dash is y1 minus 3y2. Okay, so again we will assume that let x equal to k e raised to the power lambda t is the solution, and in this case I am assuming it is supposed to capital Y. Okay, capital Y equal to, this is the solution. So when you substitute in this equation, you will get y dash equal to, what is that? Or first I will write this in the matrix form, that is nothing but y dash equal to a y. Okay, where y dash is y1 dash and y2 dash, and what is a? A is nothing but minus 3 1 1 minus 3. Okay, and y is y1 and y2. So on the basis of that I can write this. Now find the derivative of this and substitute here. So after solving you will get a minus lambda I k equal to 0. Again this is the eigenvalue problem. So to get the non-trivial solution, to get non-trivial solution, the determinant of this must be equal to 0. And for that, what will be the determinant? Determinant will be minus 3 minus lambda 1 1 minus 3 minus lambda equal to 0. So what is the characteristic equation? You will get like this. Okay, and you can see that this is nothing but plus minus 1. So lambda will be, one solution will be minus 4 and lambda 2 will be minus 2. So you get 2 lambdas. Okay, now I will substitute this lambda 1 into this equation and I will get eigenvector. Okay, so for lambda 1 equal to minus 4, so what will be that matrix? You can see that will be minus 3, that is, yeah, so minus 3 minus 4 minus 1, oh, that is plus 1. Okay, and plus minus 3 minus 4, and this is k1 k2 equal to 0 0. Okay, so this will be, oh, this will be plus 1 because it's a minus 1. So this will be 1 1 1 1 k1 k2 0 0, and you can see that this row is same as this. If you use Gauss elimination, so you can see that this row is exactly like this. Then there will be only one solution, that is k1 plus k2 equal to 0. So what will be the k1 matrix? Capital K1. This is the capital K1. Okay, because there will be two eigenvectors. So capital K1 will be 1 minus 1. If you take K2 equal to T, then you will get K1 equal to minus T. So I can write one eigenvector as a 1 minus 1. Okay. This is for lambda 1 equal to minus 4. Okay. Now for lambda 2 equal to minus 2. If you solve, you will get minus 3 plus 2, 1, 1, minus 3 plus 2. Okay. In this case, you will get minus K1 plus K2 equal to 0. And this row will also be same. Actually, so second row will be something like this. K1 minus K2 will be 0. You can see that both equations are equivalent. So what will be the eigenvector in this case? That will be 1, 1. Okay. Now combine the solution. So the solution will be C1 K1 e raised to the power lambda 1t plus C2 K2 e raised to the power lambda 2t. Okay. The solution will be C1, and what is the K1? 1 minus 1 minus 4t plus C2, and this will be 1, 1. This is the solution of this system of first order linear differential equation. Any doubt? Tell me.
No, sir.
Everything is clear, bro? Is everything
Yes,
clear?
sir.
Is everything clear? Tell me.
Yes, sir.
Yeah. Okay. So there are two more cases. Case 2 are if roots are repeated. Roots are repeated, but don't worry, I will not discuss it. Roots are complex. Okay. Because since these two topics are out of your scope, so I will refer one book, that is Differential Equation by Dennis G. Gill. Okay, you can refer this book to get another two cases. Okay, I'm not discussing. Fine.
So these two cases are in syllabus or not?
Actually, this system of first order linear differential equation itself is not in your syllabus, but I discussed it because I saw that one question GATE has asked. Actually, that question was very simple, and they asked like this. Suppose this is the system of differential equation, then if we write this differential equation is something like this, then what is the matrix A? It's very simple, no?
Yes, sir.
Yeah, they asked this problem. If the system of first order differential equation like this, if we write this differential equation in this form, then what is the matrix A? That was the 1 marks question. So you can solve that very easily, but we don't know. We don't know because maybe at some point of time they can ask. Suppose this is the solution. They may ask like this. I mean, in the you can say that in the inverse manner they can ask. Suppose this is the solution of the differential equation, then which of the following is the corresponding differential equation? Are you getting what I'm trying to say? Are you getting it?
Yes, sir.
I am saying that they may ask one question is something like this. Suppose this is the solution of one differential equation, then which one of the following differential equation is the solution of this equation? So they may ask in the inverse manner. Okay. So, but if you know how we can solve this differential equation, then you can easily mark the correct option. That's why I discussed it. Okay.
This K1 and K2 are the vectors.
Yeah, eigenvector. This is the K2, this is the K1. But here K1, K2 are scalars. That is actually solution of this. Okay. This is capital K, this is small k. Okay.
Yes, sir. Yes, sir.
Yeah. So if you are very interested to get what is the root of the repeated and complex, then you can see, you can refer this book. That is not a very big thing. You can see that. Okay, if you are interested. Okay.
Yes, sir.
Yeah. So yeah, today's lecture is over. In the next lecture, I was thinking today to finish the Laplace transform, but I didn't get the time. But in the next lecture, I will discuss Laplace transform. Okay, and I will finish that.
Okay, sir.
Fine. And we will also see that how we can use the Laplace transform to solve the differential equation. Okay.
Yes.
Okay.